Hello everyone, welcome to online session on building structures 4. This is a second session on steel beams, and in today's session we are going to learn about different types of beams based on lateral buckling. So we have, and also the connection of a beam to beam connections and different types in that. So let us start with whenever a beam is whenever a load is applied on a beam may undergo a lateral buckling, and to avoid that lateral buckling we can provide a restrainment to the structure or restrainment to the structural element or elemental components. So such beams are called as laterally restrained beams or laterally supported beams, and the ones which are not provided with the restraints or additional supports, those are called as laterally unrestrained beams or laterally unsupported beams. So here lateral restrainment can be provided by providing a compression flanges embedded into the concrete. So what I can do is, if I have a floor slab and I am providing a universal beam I section, the compression member of the compression component of the universal beam can be embedded into the concrete. So when I apply the load, there because of this embedment, the I section is not allowed to buckle in a lateral direction. And if it is unrestrained type, like this, if I provide a beam and above this beam I'll provide the concrete slab, and I can just fit it, either it is just a simple support, or I can weld it, or I can provide a nails into it. So by providing this type, this universal beam is possible to buckle in a lateral direction. Second one is, if I am not providing the embedment, I can also provide the lateral restrainment by providing a shear connectors like this. A compression flange of a beam is provided with the shear connectors such that the compression flange is rigidly connected or completely connected into the concrete. So the lateral buckling will not occur in the embedded or the universal beam, whereas in normal laterally unrestrained beams we won't provide any type of a shear connectors. Third one is, the difference is, because of either a embedment or because of a shear connector, the compression flange of the beam is restrained against rotation, and whereas in the laterally unrestrained beams, compression flange is free to rotate. And the fourth difference between these two is, a lateral deflection of a compression flange will not occur, whereas in unrestrained beams a lateral deflection will occur. Let us study about different types of connections in beam to beam connections. Suppose I have a one main beam like a girder and one secondary beam, you can call it as a joist. So what I'll do is, I'll connect this main beam with a secondary beam, and this junction is called as a beam to beam connection junction. So this is isometric view where I am connecting a girder with a joist by providing a framing angle. You can also call it as a cleat angle, a framing angle. So you can see the elevation from this side. So if I am looking from this side, I can see the I section of a girder. Then this is a primary beam, girder is a primary beam, whereas joist is a secondary beam. If both the types of beams are of same size, that is a same depth, then you can connect it on a same level on both the sides. But if any one of the beam is bigger side and other beam is a smaller size, then make sure that you connect the top flange on a same level. That is, if this depth is more and whereas this depth is smaller type, then make sure that the levels of the top flange are on the same level, whereas bottom can have a difference. By providing this, the advantages or the reason for providing such arrangement is this will give us a flat or unobstructed floor on the upper floor. So here, since these two flanges are on the same level, I can make a cut on this side, that is here I can make a cut, a slight cut, and then I can join a web of this joist to the web of this girder by providing a framing angle, and bolts will be provided on both the legs of the angle. One leg will connect the web of a girder with the angle leg, and another leg is connecting angle leg with the web of a joist. So this is how a typical beam to beam connection is provided. If I am using a welding, same method can be adopted, but instead of a bolts I can replace it with a weld. In this there are different types. Beam to beam connections are of different types. First we'll start up with using a double angle web cleats. Web cleats are nothing but the cleat angles which are used for connecting the web sections. So here you can see there is a girder section and there is a joist section. This is a side elevation and this is also a side elevation. This is a side elevation from the girder side and this is a side elevation from the joist side. So if I am looking by standing in front of a girder, cross section of a girder, I can see that the depth of the girder is full length, that is, this is the cross section of a girder. Then a joist is arranged in such a way that I am providing a single cope. This is a single cope in the sense I am making a cut section so that I can provide both the flanges on the same level. So this is called as a cope. This is the supporting beam and this is a supported beam. So I am providing this beam which is resting on this beam. And this is a web cleat. Web cleat because this is a cleat angle section which is connecting two web sections of a girder and a joist. So if you look it from this side, that is when you are looking from this side, you can see the cross section of a joist and the full length section of the longitudinal section of a girder, and these are the cleat angles. Cleat angles are always provided on both the sides. That is, if I am connecting this web to this web, I have to provide one cleat angle on left side as well as another cleat angle on the right side. Second one is where I am providing a double cope or a double angle web cleat. So here I am providing, suppose a joist and a girder both are of a same dimensions, that is both depth are of a same dimension, then I can provide a cope on this side also, a cope on this side also, and both flanges will be at the same level. This is from the girder side and this is from the joist side. You can see a double cleat on left one side and right one side, and when you are looking from the girder side you can see only the single cleat and another cleat will be on the back side. Another type of a connection is a typical beam to beam connection using a flexible end plate connection. So whenever we order a beams of prefabricated beams, or as per our requirements, beams can, if I provide actual length of the beam, I'll be getting a beam along with a end plate. Suppose this is a beam, then at the end of this beam there will be a end plate which is just of this dimension, exactly of this dimension, which is a prefabricated. So if I have such type of a end plates with the beams, then what I can do is I can connect this web of a joist with a web of a girder by providing a bolts on the plate. So here a web of a joist will be provided with the end plate, which is a welded type, and then the welded web plate will be connected to the web of a girder by providing a bolting. So you can see in this way. Last type of a connection is a fin plate, by using a fin plate. Fin plate in the sense it is not provided with a previously prefabricated plate, but or at the end of the beam, anywhere we can join the fin plate wherever we want to connect a beam. So here fin plate, it can be of either a long fin plate or it can be of a short fin plate. In long fin plate, two joists are connected with the web of the girder by connecting a long fin plate. Here these are connected by bolting, these are connected by bolting, whereas this can be a welded type, that is here near the web I can provide a weld. Second one is a short fin plate, where the distance between the two joists will be very least. So these are the different types of a connection in a beam. In next session we'll study about types of connections from beam to column. Thank you.